They were shocked because recently they found evidence of much more recent geological activity. In fact, they think that it was still active based on the some instruments that they left on the moon by the Apollo astronauts. They think that it might very well still be active today.
Hello, everyone. Welcome to the Creation Podcast, the show where we discuss the science that confirms Scripture. I'm your host, Trey, and I have with me today Dr. Jake Hebert, ICR physicist. Thank you so much for being here, Dr. Hebert.
Thanks for having me.
Of course. How are you doing today?
Doing all right.
Doing all right. All right. Are you ready for this?
Oh, yeah.
Okay. All right. So we're going to talk about something that I think has just kind of captured the minds of the human populace at large. We're going to talk about our solar system, which is, of course, part of space, which is very big. So evolutionists claim that everything that we see is like 13.8 billion years old. Is that?
Well, they claim the universe is 13.8 billion years old. Although recently there was a guy out there who was toying around with the idea that maybe it was twice that old because there was data from the James Webb Space Telescope that was giving them trouble. I wrote an article about that. I don't know how many of these evolutionists are going to take that seriously. But yes, they would say the universe is 13.8 billion years old, and they would say our solar system is about 4.6 billion years old.
All right. Well, either way, it's an unimaginable, unimaginable amount of time. I can barely conceive of more than 100 years, much less that.
Right.
All right. So I've heard you say this before, that there is a lot of evidence of youth in our solar system. So that's what we're going to talk about today. We're going to look past Earth itself into our solar system, and we're going to look at some of that. Before we jump into the specifics, I'd like to know, from your point of view, why is it important that these features even exist? Why is it important that there are signs of youth in the solar system? What does it mean to the creationist? What does it mean to the evolutionist, et cetera?
Well, it basically is a test, right, for which worldview is correct. The evolutionists claim billions of years, creationists are saying thousands of years. And so obviously the question is, where does the preponderance of evidence point to? Is it pointing to youth, or is it pointing to something unimaginably old? And I think the preponderance of the evidence favors youth, especially in the solar system. Now, I understand how some people get tripped up over distant starlight and things like that. But when you look in the solar system, you see youth everywhere. It really does look young. And the thing is, some of these age indicators are very young. When we talk about the Earth's magnetic field, that I think we'll probably bring up here in a little bit, we're talking tens of thousands of years upper limit for the age of the Earth. Okay, so if you've got these strict limits of just a few tens of thousands of years, that pretty much blows away evolution, and we just see evidence of this everywhere.
Okay, well, you already mentioned the first thing that we're going to talk about, so let's hop into that. Earth's magnetic field. So technically still a part of Earth, but not one of the signs that we usually point to, like rocks and whatever. Right. So Earth has a magnetic field. What does that even mean? Well,
everybody's familiar with bar magnets, okay? Right. And so we know what a magnet is. Well, the Earth is a kind of magnet. But unlike the bar magnet, okay, the magnetism is caused by the spin of electrons. Okay. Now, when you're talking about the Earth, the magnetic field is caused by an electrical current. Now, basically all magnetism is caused by moving charges. Even the magnetism of a bar magnet is technically caused by moving charges. But you've got a current. We think there's a current in the Earth's interior that generates that magnetic field. So you need a moving charges to generate a magnetic field. So, and of course, that's, why, if you take a compass needle, it's going to line up due north, it'll point north.
Right.
So the thing about this, though, is that if you need moving charges to generate a magnetic field, in this case, an electrical current, Well, the problem is electrical currents die down over time. And so if you're an evolutionist and you believe that the Earth's magnetic field is billions of years old, you have to have some kind of mechanism that can keep that magnetic field going for billions of years. So you need to keep the current going for billions of years, and that'll keep the magnetic field going for billions of years.
Got it.
Well, they have a theory called a dynamo theory, but they've been working on it for over 100 years, and it's got major problems. And not that long ago, a geophysicist said that we just don't know how the Earth's magnetic field has lasted for billions of years, and that they were encountering problems, more problems than they thought. They had a poorer understanding now than they thought they did 10 years ago.
Wow.
So right there, that's an indication that the Earth's magnetic field is a strong indication of youth. But it's even stronger than that because we can make measurements, historical measurements of the strength of the Earth's magnetic field, and based on those, we can figure out how quickly the field is running down.
Kind of like a half-life?
Yes, exactly. So you've got a half-life for the energy of the field. It's about 1,400 years. And so if you run the numbers backwards, a few tens of thousands of years ago, the energy to sustain that magnetic field would have generated so much heat it would have melted the Earth's crust and mantle. So that's a very strong upper limit on the age of the Earth. And so that is a very strong indicator of youth. The Earth is very young.
Okay, because according to the evolutionary thought process, even at that upper limit of the magnetism, where it would be melting everything, there were living creatures and beings that would not have survived, right?
Right, okay. Sure. Oh, yeah, absolutely. And of course, now what they would argue that it's flipped directions. And of course, we think it's flipped in directions as well in the past, primarily triggered by the flood. But obviously, if you've got an upper limit of just tens of thousands of years, that completely rules out evolution.
Side question: if the magnetic field flips, does that mean that when it's flipped, would a compass hypothetically point towards the South Pole instead of north?
Yes.
Okay.
Yes, it would. It would. Sure. Yeah.
Very weird to think about. All right. I don't know if that helps the age of the Earth argument, but it's just interesting.
Well, yeah, it's the energy is what's important. That's running down. And they wouldn't. I don't think they would try to argue that the field was that strong in the past. But if you just look at the historical measurements we have and you run them back, that's the trend we see.
Right. And you need measurements to actually make predictions.
Yeah, exactly. Or in this case, retrodictions, going backwards in time. Yeah.
Retrodictions. Yeah. I did not know that word.
Okay, all right,
you.
Yeah. Uh-huh.
All right, so from a creationist point of view, what does this decaying magnetic field mean for us?
Well, it means the Bible's telling the truth about Earth history, okay? The Earth is young. The solar system is young. And there's lots of other indications of that as well.
And we're going to get into some of those here?
Sure.
All right. Moving a little bit away from Earth, we're going to talk about, we'll say, geologic activity in the solar system, not on Earth. Okay. So geologic activity, from my understanding, requires energy, kind of like the magnetic field. And so if there's going to be any sort of geologic activity, it means that there's an energy source. And that energy source would also run down, kind of like the magnetic field. Right. So what are we looking at in our solar system as far as geologic activity apart from, I guess, volcanoes on Earth?
Well, you've got the moon, okay? The moon, for a long time, evolutionary astronomers said that the moon had been geologically dead for the last 3 billion years. Well, they were shocked because recently they found evidence of much more recent geological activity. In fact, they think that it was still active based on the some instruments that they left on the moon by the Apollo astronauts. They think that it might very well still be active today.
Okay.
And basically what's happening is the moon is slowly cooling off, and as a result of that, the crust is shrinking ever so slightly. And so you get these features that they call scarps, where you have these kind of escarpments that, because of this shrinkage of the crust. And they were just shocked by that. And so I think most evolutionists now have had to admit that the moon has been active geologically recently and probably still is geologically active. Okay. And so they were very surprised by that.
Well, where do evolutionists think that the moon came from?
Well, the most popular idea is there was an impact. Okay. That something slammed into the earth and somehow you got the moon from that. But there's problems with all of their evolutionary explanations for the moon's origin. In fact, there's sort of a joke. One Harvard astrophysicist is reported to have told his class once that the best explanation for the moon was observational error. The moon doesn't really exist because they were all having these troubles explaining its origin. So they don't really have a good explanation for the origin of the moon, although that impact theory is probably the most popular one. Okay.
Could, from their point of view, playing devil's advocate in this sort of sense, from an evolutionary point of view, could, if the impact theory were to be correct, would you see geologic activity in the moon?
Well, I don't know. I'm not sure it depends as much on the means. Okay. They were basically what's happening is the moon is still cooling off.
Yeah.
Okay. And they think it's billions of years old. After billions of years, you would have expected it to have pretty much already reached pretty stable temperature.
Right.
So the fact that it's cooling off is hard for them to explain. And I'm not sure that's necessarily the details may depend on the model, but I think that's just a problem in general for their belief in billions of years.
Okay.
Yeah.
And so for us as creationists, I mean, we know from Scripture, it specifically says that, God created the moon.
Right.
So from a creationist perspective, what does the youth of the moon mean for us?
Well, I mean, it's, again, every time you see these indicators, okay, these are clues that we live in a young solar system, a young Earth, and that's confirming what the Bible says about history.
Okay.
Yeah, and of course, now I can guess what some evolutionists will say. Oh, well, that's just one little thing, and they would argue there's this preponderance of evidence for an old solar system, and I just don't think that's the case. There are a few arguments they have, like radioisotope dating, but even the radioisotope dating method is problematic. And I think when you look at the big picture, I think there's far more evidence of youth than there is of a great antiquity.
Okay.
Yeah.
Side thought that I just had is like, well, the moon, it has like such purpose, like in when I think about it, like I think of signs and seasons. I mean, up until the modern era where we had clocks in such a way, it's like people used to tell time by the moon. Yeah. And the tides, and I think about like such purpose, and it's kind of crazy that there would be, aside from its youthfulness, like this idea that, well, it's just kind of an accident. It's just kind of there.
Right. There's a lot of quote unquote accidents like that.
Yeah. Too many.
Right. Too many. Yeah. Too many to be plausible.
Well, I would like to then stop for just a second. We're going to take a brief break. Take a deep breath. How are you doing?
Doing okay.
You good? Doing good? Okay. So we're going to step aside and have our random science question of the day.
All right.
This is really important. People on the internet are up in arms about this. We get comments about it, and it's about our favorite planet, sort of. Pluto.
Okay.
Okay, so I was growing up, I'm sure when you were growing up also, Pluto was a planet. It was the 9th planet in the solar system. Something happened. It got its status revoked. It got demoted. Why? Should it be a planet? Is it still technically kind of a planet? What's up with Pluto?
Well, basically, they found a bunch of objects near and beyond, Neptune, that some of them are about the same, roughly the same size as Pluto.
Okay.
So, do we want to add a whole bunch of extra planets to the list, or would it be better just to take Pluto off the list? And so I think that was a big part of the reasoning right there, and I can understand why they would do that. It's because we're talking to quite a few large bodies out there, and so
a dozen. More?
The really big ones, I'm not sure how many there are, but there's enough that it could be problematic.
Gotcha.
Okay, do you want to have a list of 15 to 20 planets, or would you rather just have 8?
All of a sudden, elementary school kids have their astronomy classes get a lot harder.
Right, yeah, oh yeah.
Okay. Now, science aside, how do you feel about Pluto losing its status?
It doesn't matter to me. I don't really care. I don't get worked up about it. Yeah.
I've literally seen people be like, "It's not fair. Pluto's still a planet in my heart." You know,
right,
it's like, all right, I didn't know that you were this emotionally attached to a hunk of rock.
Right.
All right. Well, thank you. Thank you for sharing with me that wonderful fact. Pluto, you will be missed, even though you're still there.
Right.
Okay. Jump back into the conversation at hand. Other warm bodies in the solar system. We've talked a little bit about the moon and its youth. Are there any other objects, we'll say planets and moons, in our solar system that really indicate youth?
Yes. Yeah, anytime you see a warm planet or moon that is pretty small, that's potentially an argument for youth.
Okay.
The question is, do evolutionists have a plausible mechanism for keeping that planet or moon warm for billions of years?
Okay.
And in a lot of cases, they don't. Now, in some cases, it might be debatable, but in a lot of cases, they don't.
Okay.
The fact that Mercury has a magnetic field. Well, they were surprised by that because Mercury is very small. They thought it would have cooled off by now. And not only that, it doesn't spin very fast, and that's another problem for their dynamo magnetism theory.
Okay.
You've got many of the moons of Jupiter and Saturn show those same characteristics. They some of them like Io, Ganymede, 2 of the moons of Jupiter, they look young because Io is the most volcanically active body in the solar system.
Right.
It's very small. Now, typically, there's like 3, as a general rule, there's 3 mechanisms that they use to explain, or that you could use to explain why a small body is warm. One would be radioactivity.
Okay.
The problem sometimes, though, is that radioactive elements are very heavy, and based on the sizes and densities of some of these moons and planets, that's really not an explanation. You can't use that one.
Okay.
The other one is it could have leftover heat from its creation. Okay, whether you're an evolutionist or a creationist, we'll just say from its origin or creation. The problem for them, though, is that in a lot of cases, this heat should be dissipated after billions of years.
Right.
So that's usually not a mechanism that an evolutionist is going to invoke.
Because they've already set the timeline.
They've set the timeline, and it should already have cooled off. The other one is something called tidal flexing, where you have gravitational tugs between 2 bodies, and that can stretch the interior and warm it up. And sometimes that may work, sometimes it doesn't. And but I think for most of these bodies, like Io, it's problematic. Mm-hmm. They think that tidal flexing might work if you make certain assumptions about the interior of Io. For instance, you have to assume it has a magma ocean and there's a crust. There's got to be just the right thickness. Well, we don't know if that's true or not. Mm. So maybe it would work, maybe it wouldn't. And in the past, we had made a big deal about the fact that their tidal flexing models could only generate a small fraction of the heat that was observed.
Right.
Well, not too long ago, that's sort of been called into question because someone has pointed out that, before they were only considering the tug between Io and Jupiter. Well, apparently there may be, the tugs from the other moons may be significant
and
as well.
There's a lot of moons.
Yeah, there's a lot of moons, yeah. So I would not make that argument anymore. However, Io, I think, is still strong evidence for youth because basically they've only got a couple of options. One is to assume that the volcanism started recently, and we just happen to be lucky enough to see it at a special time. Now, one object that might not be such a big deal, but you see dozens of examples of this.
Right.
And for mainstream astronomers, they don't like that because that seems wildly improbable. Why are we so lucky to be seeing these short-lived phenomena in our solar systems? For instance, the rings of Saturn. Mm-hmm. Okay, they should be gone in probably a few 100 million years. And they think they can only be maybe 300 to 150 million years old. Okay, so that's 450 million years, which is a tenth of the alleged age of the solar system. Why are we lucky enough to be seeing that?
Right.
Why are we lucky enough to be seeing volcanism on Io? Why, and things of that nature?
Right.
Or you could say, well, for some reason, it's been going for billions of years, but we're not sure that will work.
Right.
So
how does it keep going?
Yeah, how does it keep going? So there's lots of things like that. Enceladus, you've got these cryovolcanic geysers that are shooting off. That takes energy to propel those. They even think that there might be subsurface oceans on some of these moons, like
liquid water.
Liquid water, like for instance, Enceladus and Europa. And, Enceladus being one of the moons of Saturn, Europa being one of Jupiter's moons. Now, when they talk about that, as creationists, we usually kind of roll our eyes in the back of our head because that's almost always in the context of looking for alien life.
Right.
They want so badly to find evidence of alien life because they think that will make the evolutionary story seem more plausible. Well, it's not a good argument because
Right.
water is actually a problem for these origin of life scenarios.
Okay.
You need water for life to exist, but it can also break down these chemicals that you need to form life. But what I think sometimes gets lost in the big picture is how plausible is it that you could maintain a subsurface ocean of liquid water for billions of years? Even evolutionists admit you would need a delicate balancing act. Okay, if for this to go on for billions of years, it would be almost a miracle because you have to balance the heat in and the heat out so that this thing remains a liquid.
Right.
So again, what are the odds of that going on for billions of years? Or maybe we just got lucky again, and maybe these subsurface oceans are recent and they won't last very long. Well, again,
same issue.
What are the odds?
Yeah.
What are the odds of that happening? So we see all these indications of youth. Pluto's the same way. There's indications of possible volcanism on Pluto, but it's so small. Where does the energy for that volcanism come from? You don't really have. They were surprised. They were very surprised to find evidence of geological activity on Pluto.
Yeah, when I think of Pluto, not that I know too terribly much
Right.
about it, but I just think of like a hunk of rock with nothing going on.
Well, it's funny. One of the principal investigators for the New Horizons project, which was the probe they sent to Pluto recently, it was almost like he was anticipating that we creationists were going to pounce on this because he says, well, we can't use youth to explain energy sources. It's like, well, why not?
Yeah.
Sure, we can. Maybe you can't as an old Earth evolutionist, but we can. So,
Right.
So there's just lots of indications of this kind of thing throughout the solar system.
Okay. We're about to hop into one of my favorite examples of youth in the solar system. I just think, honestly, they look cool. Maybe I'm shallow. I think they're cool. But let's talk about comets.
Comets, right.
So when I think of comets, I think of like, oh, you see it, flying across the sky. That's really cool for us on Earth. It like looks cool. Mm-hmm. But I mean, there's something going on there. So what is a comet? What is it made of? What is its purpose if it has one? What's going on there?
Well, they've been described as dirty snowballs.
Okay.
And the average comet, I think, is about, what we call comet nucleus, is about 10 kilometers across. So it's not very big.
Seems big to us.
Yeah, but I mean, compared to the size of the moon or the Earth, yeah, it's not that big.
Okay.
But basically what happens is when they come near the sun, the radiation from the sun causes some of these ices that are in the nucleus to vaporize. They go directly to a vapor state, and so you get these long, beautiful tails. But what happens is every time that happens, they're losing material. So they're kind of like melting ice cream cones.
Okay.
And the problem for evolution is that these are supposed to be leftovers from the formation of the solar system 4.5 billion years ago. And the typical comet, if it were to continuously spew this material, we're looking at a lifetime of maybe 10,000 years, something on the order of 10,000 years. Exactly how long depends on how frequently it comes by, things like that. But so these things really shouldn't be able to survive that long. But yet we still see comets in a solar system that is supposedly 4.5 billion years old. So we think as creationists, that's a strong argument for youth, that the solar system is young. Now, obviously, mainstream astronomers are aware of that problem. They claim that there are reservoirs of potential comet nuclei that can restock or resupply the solar system with comets.
Have we seen those?
Well, it's okay. Let me put it this way: there's more than one. They need more than one reservoir because different comets have different orbital characteristics. Okay. Some of them have very inclined orbits, where they're at a big angle to the plane of the solar system. Others are close to the plane of the solar system. So they have two reservoirs that they invoke. One is called the Oort cloud, which is this a cloud of trillions of comet nuclei that is supposed to be farther out than we can observe, but the idea is that every now and then a comet will get perturbed, it'll fall in toward the solar system, and that's the source of what we call long period comets.
Okay.
Comets that take more than 200 years to go around the sun.
Okay.
On the other hand, you got short period comets, and those are thought to come from what they call either the Kuiper belt or the scattered disk. Now, there is a Kuiper belt, there is a scattered disk, but there's a question as to whether or not it's got the right kind of things for comets.
Where is this belt?
Well, it's beyond Neptune. And a lot of creationists don't even like the phrase Kuiper belt because we prefer the term trans-Neptunian objects, because the term Kuiper belt is a little bit loaded because it kind of presupposes in people's minds that you've got enough objects there to serve as this reservoir.
Gotcha.
And we question that. Now, Pluto is a trans-Neptunian object.
Right.
There are objects out there, but most of them are pretty big. Most of them are at least 100 kilometers across.
Okay. Too big for a
Too
comet.
big. Now they would say, well, maybe there's smaller ones we can't see. But I'm not going to be dogmatic about this, but the sense I get reading the literature is that they're having a problem finding the smaller ones.
Okay.
That I've only seen two objects. I'm just kind of scanning the literature. I know there's two objects they found that are, maybe between, 20 kilometers, something like that, maybe 40 or 50. There is a dearth of very small ones between 1 and 2 kilometers. Okay, they figured that by looking at the cratering patterns on Pluto and Charon. Now, I don't know if that means the 10-kilometer ones are also rare, but the sense I get, I think there's a serious question as to whether or not this belt of objects, it has got enough material in there to restock the solar system.
So from my understanding of kind of how this process works is they need a source.
Yes.
Like they need a source. They see the comets and they're like, well, it makes sense if it's young, but we know that the universe is old.
Right.
So we've got to make sure that there's a reservoir of these, but the reservoir itself is like, there's no proof.
Iffy.
It's iffy.
Yeah,
okay.
one of them, there's a serious question as to whether or not it even exists.
Right.
Okay. These other objects, the scattered disk, whatever you want to call it, the Kuiper belt, whatever you want to call it, there's objects out there.
Yeah.
But it's not clear that you've got the small objects out there that you need. And I know they've been looking for them. They've got surveys that have been dedicated to trying to see small, what they call Kuiper belt objects, KBOs. And it gets complicated, because, for instance, a while back they had proposed that maybe some of the Halley-type comets came from this region, the scattered disk, which is kind of part, I guess it depends on how you define it. Sometimes people say the scattered disk is part of the Kuiper belt, depending on how you define it. But they were saying, okay, well, we think maybe the Halley comets came there. Well, then they said, oh, no, there's not enough material. We've only got 1/10 the matter we need or mass to account for these. Okay. They said, okay, well, maybe the Halley-type comets, which is it's a category of short period comet, one particular kind, maybe they're coming from the Oort cloud. Well, that's all well and good, but again, there's no direct evidence the Oort cloud even exists.
Right.
Now, but it's worse than that. And I think we creationists need to double down on this, because it's not just that you don't have direct evidence for the Oort cloud. There's a lack of indirect evidence.
Okay.
And I'll give you an example of what I'm talking about. In 2003, Sky and Telescope magazine had an article called The Case of the Missing Comets. And if you go to their website and you get on their search engine and you look it up, I think you can still pull up this article. But it's The Case of the Missing Comets. Now, these long period comets that are supposed to come from the Oort cloud, what happens to them after they've expelled all their gaseous material? Well, essentially you should have nothing but rock left.
Right.
And so you should have these dark, I guess kind of like asteroids. I mean, they're not really asteroids, but they're left over. They've gotten rid of all their icy material flying around. And so this guy did a study, and he has figured that based on the assumption that the Oort cloud is real and that you've got, it's supplying the solar system with comets, 99% of all the comets coming from the Oort cloud ought to disintegrate. Now, we know comets can disintegrate.
Right.
We've seen that happen, but 99% of them, I have a hard time believing that. And the question is, maybe they just don't exist.
Yeah.
It's not just we can't see the Oort cloud, we can't even see the leftover remnants of comets that are supposed to be coming from the Oort cloud.
Right.
And there's all kinds of other problems. So I think creationists, we can make the argument even stronger. It's not just that there's no direct evidence for the Oort cloud. I think there's a lack of indirect evidence for it as well.
Wow.
Yeah.
Okay. Question about what about any sort of comet that comes from beyond our solar system? That was just a thought that popped into my mind. Like, I guess just random stragglers. I don't know where.
Well, there's a potential problem for them there as well.
Okay.
Because they've done studies where, the idea is that you have these gravitational perturbations, and that causes these comet nuclei to fall in toward the solar system.
Okay.
Well, they've done some studies, and they think they're actually more likely to get ejected away from the solar system. Well, if you've got other solar systems and they're like ours, and they've got their own Oort clouds, they ought to be kicking these comet nuclei out as well. And so where are they?
Yeah.
We've seen maybe one or two, a handful maybe, of possible extrasolar comets. I'm not even sure. Even that's debatable.
Right.
There's one that maybe it's an asteroid, but there's a potential problem even there. And another problem is that they think these comet nuclei had to migrate way out away from the solar system. Well, there was an earlier paper, I think around 2002, that said basically most of them would have gotten destroyed on the way out.
Yeah.
So there's all kinds of problems with the Oort cloud and with the idea that they can restock the solar system with comets. I think comets still are a very strong argument that the solar system is young.
Okay. Wow. And they're just like ice.
They're
ice
pretty.
balls.
Yeah. They're like melting ice cream cones.
Yeah. Okay. Yeah. Awesome. Well, that's incredible. Before we wrap up, I want to, creation science has, there are arguments that have shifted since the movement has started. I'd like to hear from you. Are there any poor arguments that you would tell our viewers and listeners who are creationists not to use when it comes to the age of the solar system?
Sure. Well, I can think of two right off the top of my head.
Okay.
One is and some people are going to get mad when I say this. But
I'm already angry.
But I question the lunar recession argument.
Okay.
This has long been a favorite argument for a young moon and Earth because the moon is slowly moving away from the Earth.
Okay.
It's about, I forget what, 1.5 centimeters per year, something like that. It's a small amount. And the thing is, if you run the numbers backwards, okay, the moon is going to get closer. It's moving away, so it would have been closer in the past. And if you run the numbers backwards, you would have the moon touching the Earth 1.5 billion years ago.
Right. Okay.
Now, the problem is it would get ripped apart even before that.
Okay.
So that's obviously nonsensical. You can't have the moon touching the Earth. You can't have the moon that close to the Earth. And so this has long been a favorite argument of creationists for youth, for the moon. The problem I have with this argument is that these calculations are really, really hard.
Okay.
And nobody, creationists or evolutionists, have done the full-blown calculations without making simplifying assumptions.
Gotcha.
And the assumptions that you do to get that number of 1.5 billion years, they start to break down the farther back in time you go.
Okay.
And so it's like, in fact, I am only aware of, I believe, one paper that tried to go back, I want to say 150 or 300 million years.
Okay.
And it was pretty rigorous. And they said, well, if you do that, it might work. Well, okay, but you need to go back 4.5 billion years,
right,
to be sure.
You need to keep working at it.
So the thing is, I've got great reservations that anybody's ever going to be able to do that. I mean, the math is just so hard.
Let's just ask AI to do it.
Yeah, right. So I don't think that's an airtight argument.
Okay.
And by the way, people should not get hung up on the number 1.5 billion years.
Right.
The bigger issue is, if you believe the solar system is old, there's a possibility that the moon should no longer exist.
Right.
The history that you're implying about the solar system might mean the moon should no longer exist. Now, whether it would have been destroyed 1.5 billion years ago, 500 million years ago, really doesn't matter. The question is, the moon obviously still exists.
That reminds me of like the soft tissue. They're like, well, it could last 100,000 years,
Yeah.
which isn't 6,000 years. And it's like, yes, but it's also not
Millions of years.
millions and millions of years. Yeah.
So, I'm not sure this is an airtight argument.
Okay.
Now, but you can safely say young Earth creationists don't have a problem.
Right.
Because the moon is only going to recede a small distance in 6,000 years. The only people who potentially have a problem are old Earthers.
Okay.
But I think we should acknowledge that it's not a slam dunk.
Okay.
Because, again, the calculations are super hard, and I don't think anybody has done this without making simplifying assumptions. And those assumptions start to break down the farther you go back in time.
Okay.
So I would use caution. I probably wouldn't use that argument, but if you do, you need to acknowledge that it's not airtight.
Okay.
Okay. Another one that I've recently started to wonder about is Jupiter. We've talked about the fact that Jupiter is radiating more heat than it's receiving from the sun. And about 20 years ago, a creation astronomer named Ron Samick did a paper on this, and it was a good paper. And it pointed out how this was a problem for the evolutionists, because there were ways you could try to account for that heat imbalance, but they were all potentially problematic. The thing is, though, the one remaining option they had to explain the heat imbalance was something called gravitational collapse, where Jupiter would be slowly shrinking, and that would generate some heat. Since then, they've come out with some more recent solar system origin theories where you might be able to get the moon to form, Jupiter to form quicker.
Okay.
So I'm not sure that's still a completely airtight argument. I've used it. Okay, I'm sure they've got YouTube videos.
How dare you?
I know. I'm sure they've got YouTube videos of me on YouTube using that argument. But I recently started to think, okay, maybe we better not.
Right.
But I can tell you this: the really strong arguments when you're talking about heat balance is the small moons and planets. Okay. Those are the ones where you really got the strong argument.
The Eos. Yeah,
Eos. Io, Mercury, even our moon, things like that. Those are, I think, still very strong arguments for youth. And there's still even a potential problem, for instance, with Uranus and Neptune. Neptune is losing heat very rapidly. I think it's about, I want to say 2.5 times the energy it's receiving from the sun. I could be getting the numbers mixed up, but Jupiter and Neptune are both, there's a big deficit of energy they're losing. Even if it's not necessarily a valid young universe argument, it's still a valid anti-evolution argument, because Uranus, on the other hand, hardly emits any heat at all.
Right.
So, they think both Uranus and Neptune formed at about the same place in the solar system. They all, they're both these gas or icy gas giants. Shouldn't they be similar? Well, they're not. They're very dissimilar.
Right.
So that's a problem. That is still very much a problem. But I would caution, until we've done some more study on, these latest theories about the formation of the gas giants. I think that sort of muddied the waters on that argument.
Right.
So I wouldn't use the gas giant argument, heat imbalance argument, right now,
right,
because I think there's some question about it. But like I said, I've used it myself.
Yeah.
So,
and really the point in asking that is because it does change. And, and And I hate to say it, but a skeptic, someone who's not a creationist, people will still say, well, if humans evolved, why are there still chimpanzees, right? And it's that's not a good argument.
Right,
so
right.
We just want to make sure.
And it's hard. We want to keep up.
Yeah.
We want to keep up with the literature. So if something changes, we want to acknowledge that and try to stay abreast of all the current developments.
Well, you're doing a great job.
Well, thank you.
Yeah.
All right.
I appreciate that. Okay, so as we draw this to a close, we've seen all of these signs of youth in our solar system, which of course, to us, just confirms the authenticity and the accuracy of Scripture and the scriptural account, the historical account of Genesis, 6-day creation, just 6,000 years ago, 6,000-ish. Mm-hmm. Do you have any closing thoughts?
Well, I don't know. There's a whole lot to say, except to quote Psalm 19, the heavens really do declare the glory of God. And so not only are these objects beautiful, but they also show His handiwork, and they silently testify of youth, which is what we would expect based on the biblical account.
Awesome. Well, thank you so much for being here with me today and sharing your expertise. I definitely appreciate it.
Okay. Thank you, Trey.
Absolutely. And to all of our listeners and viewers, thank you so much for tuning in. We appreciate you stopping by and watching this episode of the Creation Podcast. We'd ask that you give it a like, share it, hit that subscribe button, and hit that bell so that you're notified of future uploads. We want to make sure that you are kept apprised of all the episodes of the Creation Podcast, but not just that, some of our other shows, our other podcasts, so that you can see those and just be up to date on what's happening in the realm of creation science. So we'll see you 2 weeks from now for the next episode of the Creation Podcast. We want to say a huge thank you to our members and patrons. If you'd like to see your name here and unlock perks like early access to our podcasts, members-only polls and live streams, behind-the-scenes footage, or exclusive video content, links are in the description below.